Hello, welcome everyone to the 10th presentation of Radiosity Surface Detail Texture for the subject Introduction to Computer Graphics by me, Ghulam Jilani Khadri. So let's start. The very first one is which we will discuss is radiosity. Radiosity is a method of rendering based on details analysis of light reflection of diffuse surfaces. Image have soft gradient surfaces. Now, in 3D computer graphics, radiosity is an application or finite element method to solving the rendering equations for scenes with surfaces that reflect light diffusely. Unlike rendering methods that use some Monte Carlo algorithms which handle all types of paths which leave a light source and are reflected diffusely some number of times. Radiosity is a global illumination algorithm in the sense that the illumination arriving on a surface comes to just directly from the light sources but also from other sources. Now we'll see others in details. We can see here the different definition of radiosity is a global illumination model that assumes all surfaces and diffuses and computes illumination. It also computes intensity reflected from each small surfaces and also emitted by the surface itself and energy reflected from other objects. In radiometry, radiosity is reflection radiate flux living emitted, reflected, transmitted by a surface unit area, and also it is the surface per unit frequency or wavelength depending upon whether the spectrum is function or frequency or a wavelength. Now, we can see here there's a mathematical definition just to calculate the radiosity, where we have the partial derivative symbol, the radiant flux, just leaving emitted, reflected, transmitted. A is the area, and emitted component, reflected, transmitted. All these components we will see in the coming slides, and we'll see how they are going to affect and calculate the radiosity. Now, as we have seen, there is term we used intensity in the other definitions of radiosity. The intensity is used in many disciplines, even closely related to optics to mean things that flux units relations. Intensity is actually, we can see here, is in physics, it is the power transformed per unit area, where area is measured on the plane perpendicular direction of the propagation of energy. Also, to be when we want to deep, it's like it's synonymous to strength, amplitude, magnitude, or level, or sometimes it is clickless pitch. So here we have intensity I is the flux per unit solid angle. It also a source can be considered a point source for this application if the irradiance falls off as inverse of distance. So it can vary in different directions. Now we can see how intensity is exactly. We have seen that we have radiance and the light which is directly coming from the sun and its particular angle which is again sensed by the sensor and earth's surface. So it's like both the strength and direction of the radiation sources contributing the flux gradient on the surface. And we have units W m square r square watts per square per meter. Now again we have intensity per solid angle. It what it is. It is like we will calculate a solid angle in a 3D angular volume that is defined analogously to the definition of a plane in 2 dimensions. We can see here we have a plane angle theta made of two lines at the vertex and also length of the circle separated by lines and radius. Also we have 2 pi and we're calculating this theta by 1 upon r in the radians and 2 full circles. Now next we will going to discuss is radiant flux, which is actually the radiant energy emitted, reflected, transmitted, received per unit time based upon the frequency or wavelength, or whether the spectrum is a function of frequency or wavelength. The SI unit is considered to be what? It may be joules per second or hertz per watt per hertz, or watt per meter, which we're gonna see in the coming slides. Total energy is here Here on over a hemisphere we have seen some mathematical formula is considered over here how we can calculate total energy. Patch I is a point for the purpose of gathering. Now we have to calculate is in the unit of radius. If we project other hemisphere, the projection will show. We will skip these slides, and now we have form factor. So consider a small area dai on the path and other path aj.